All right, we've configured our default routes on our stub routers, our end routers. But as you saw, we have no connectivity all the way across. Now we need to create our static routes. And before we do, let's talk a little bit about them. When we create static routes, what you're actually doing is you, the administrator, the network engineer, is actually creating the static routes manually. So you got to say to yourself, my God, I hope I work for a small network then, because that's a lot of work. And it is. If it's a huge network to do static routes, it's an administrative headache. But the good thing is that you control who can go where. So in this case, that won't be the problem. We have a very small network to work with. But remember, routers only know who they're connected to. So in the case of router 1, that's connected to the 10.1.1.4 and is connected to the 192.168.1.0. You need to create static routes for the 10.1.1.8, for the 192.168.2.0, and the 192.168.3.0. So we have 3 static routes that we need to create, but it's not over. What we're going to do is we're going to prepare in advance. We're going to change the administrative distance of our static routes. Why? Because by default, static routes either have a 0 or 1 for an administrative distance. And what is an administrative distance? An administrative distance is the believability of a route. The lower the number, the more believable the route. So when we do go to dynamic routing, it will never make it to the routing table. Neither RIP, EIGRP, or OSPF will make it to the routing table because of their administrative distances are way too big in comparison to the static route. So when we create these static routes, we must go ahead and configure or change the administrative distance to something higher. So let's go ahead and do that. I'm going to go ahead and open up router 1. All right, so we're on router 1. We need to go to global configuration, obviously. Now, let's create the static route, not default static, but static route. IP route. I want to go to the destination network of 192.168.2.0 that has a destination mask of 255.255.255.0. And then we're going to have an administrative distance of 150. And it didn't like that. So let's find out why it did not like that. All right, so we're going to up arrow, and we're going to go ahead and put in a question mark. Of course, we have to put the exit interface or else it'll never go anywhere. So we're going to go ahead and do an S0/0/0, and now we can go ahead and put our 150. That's just fine. Always remember, I'm just going to scroll up a little bit, and you're going to see, I'm going to point to the error that happened. Anytime you see that little symbol, at that point is where you created the error. And this happens all the time. Just know that the world is not over. Just go back and check to see what happened. Okay? So let's create our second static route. IP route 192.168.3.0, 255.255.255.0 out of the same exit interface, S0/0/0 space 150, the administrative distance. And then the last network we'll use is IP route 10.1.1.8. That's the destination network. We're not looking at IPs, we're looking at networks. 255.255.255.252. Out of the same exit interface, because we're always going out the same exit interface with the administrative distance of 150. So we're going to go ahead and copy that. We'll exit once, hit enter, and then we'll do copy, run, start. We hit enter twice so we can go ahead and get the default of start a config file. Now let's do a show IP route to look at the routing table. And you can see now that you have not only a default static, which we did previously, but now we have just S's. We have static routes telling you, hey, I want to go to this network, and it's showing that it's directly connected. And that is important. Cisco recommends on static routes, point-to-point connections, to use the exit interface. Only does one lookup on the routing table. That's important, okay? So we have static routes now. All right, let's go ahead and see if PC1, now we did this on on router 1. Let's go to router 2, forgive me. Let's go to router 2 and do the same thing. Enable shortcut method, config T, and let's move the table. Let's put it up here so we can see it a little bit better. Oops, kind of lost my eyes there. Let's move this down a little bit right here. Okay. So let's go ahead and do now. The middle router knows about the 10.1.14, knows about the 10.1.18, and he knows about the 192.168.2.0. So all we need to do is the 1.0 and the 3.0, and we're good to go. So let's go ahead and do that. IP route, I want to go to the destination 192.168.1.0, 255.255.255.0, enter. Oh, no. Administrative distance and exit interface, which we keep forgetting. And what's interesting about the middle router is that if you're going this way, you're coming this way to the 1.0, it's going to be the S001. If you were to go that way, right, to the 3.0, it will be the S000. Let's go ahead and do that correctly. All right. So we're going to go out of the S0/0/1 with the administrative distance of 150. And now let's use a shortcut method by using your up arrow on your keyboard. And we're going to change the 1 to a 0. And then with your keyboard arrowing to the left, we're going to take out the 1 and we're going to put out the 3. So to try and work more efficiently and faster, all right? So now we got both static routes. Now this router is aware that, hey, there's 2 networks out there. Let's do a copy run start. And let's do now a show IP route. Show IP route to look at what? The routing table. So now this router is aware of those networks. Beautiful. Let's do it on the last router. We're going to enable config T. Now, what do you say to yourself? Router 3 knows about who? The 10.1.18 and the 192.168.1.3. But he doesn't know about the 4. He doesn't know about the 1.0 or the 2.0. So those are the ones that we need to create. IP route. I want to go to the 192.168.2.0. That's a mask of 255.255.255.0. Exit interface is S001, 150 as the administrative distance. Use our shortcut method with an up arrow. We're going to get rid of the 2, put a 1. Right? Same exit interface, same administrative distance. And then the IP route to the 10.1.1.4, 255.255.255.252. S0/0/1, administrative distance 150. Hit enter, exit once, copy, run start, enter, because we want to accept the default file name. We do a show IP route. Now we have those networks in there. Now what should happen, we should be able to ping to whoever we want at this point. And let's see if that's true. Let's go ahead and up arrow and let's ping to 2.1. Hey, now we can get there. Let's go to 3.1. And now the first one, don't be scared. The first one, you always get a request timeout. This is IP version 4. We have that ARP request. So we got that. If we were to do it again, we will get 4 replies. So now we have full connectivity across our network using static routes. So that's one way of doing it. Default routes are nice, but you can only point them in one direction. Static routes, it can be in either directions. So static routes are the way to go when it's a small network. Now dynamic routing, it will be a lot easier on you. So let's go ahead and take a look at how to do that.